Hello, everyone. Are we ready to get started? Yes, I hear some excitement, which is good. So I'm Andrea. I'm the AI product manager at Canonical, and together with me I have our AI director, Maciek Mazur. I'm curious of something. How familiar are you with Canonical? Raise your hand. Don't be shy. 1, 2, 3.
That's not much.
That's not much. He's right. What about Ubuntu? That's what we should hear also about Canonical. So we are the publisher behind Ubuntu. And except for that, we offer solutions across all layers of the stack. And nowadays, we're working a lot on AI and offering tools that enable developers, machine learning engineers to develop and deploy their machine learning models. So my next question is quite easy before we even get started. Are you working on any AI project at the moment? Do you have experience with AI in general? Okay, so I see we have a bit of a mix in the room. We have some, I guess, more experienced people, and then people who are just getting started. The next question is, do you use open source tools? Yes. So in Canonical, we do have open source in our DNA. We will be showcasing plenty of open source tools, models, frameworks that you can use. And that's something that we always talk about. I see more people joining in, so I'll wait for a bit. Cool. Today we'll be talking on how to build a large language model factory and, in general, how to build and optimize LLMs. I'll be challenging Maciek across the session with questions. I would encourage you to do the same. We like interactive sessions. We are not here to just show things, but rather to also answer your curiosities. Okay, by now you know us, I guess. So we'll have a short intro to MLOps. Then we'll talk about hardware and infra components, because as much as we like AI and AI projects, they're still tied to hardware. We'll be talking about how to prepare the data, models, automations, MLOps, and at the end, a bit about quality. I will not make it any longer. Maciek, do you want to take over?
Yeah. Hi. So how many of you are familiar with large language models in general? Okay, so that's easy. We can almost skip that, but basically what we'll be looking into is how to utilize large language models, most likely without training them, because most of you guys will not be creating a new foundational LLM. You'll be probably using one that is coming from somewhere else, either an open source community or some other repository, right? But in order to start using them, it's good to look into how they are working. So typically they are being trained on big corpuses of text or some additional data as well. And they are not that much different than any other ML models. They still require the same infrastructure and the same training process. The main difference is the size, both of the training data and also of the capacity that you need to do any kind of inference.
Maciek, I have 2 questions now. First of all is, let's see what open source LLMs do we know from the audience. And then you have to tell me at least one as well. Different than what we hear from the audience. Let's see. Falcon, LLaMA. Okay, any other? Okay. Maciek, do you? Sorry, I didn't hear that. Okay, Falcon, yeah. Maciek, what else do you know except for what you've heard in the room?
The Vicuña is quite nice as well, depending on what type of data you are working on. NVIDIA is actually open sourcing a lot of LLMs as well, with like NeMo and Megatron family of models which are trained for specific use cases. So there are a lot of options.
And then my question is, what's the main difference, or when should we use LLMs and when should we use traditional machine learning?
That's a weird question, but basically...
that's what we get, so that's why I asked.
Yeah, sure. So basically large language models are useful whenever you want to have text being generated and text as an input. So this is just a different way of interacting with the model. The traditional ML was mostly, even if it was NLP, but most of the other techniques were focused on interacting either with different data types, with numerical data, tabular data, and so on. So it really depends on what kind of use case you are trying to build, but also if you look at LLMs in general, people are trying to apply them to various different problems because it all started with like chatbots and being able to converse, but that's not the most exciting one, and that's not how more LLMs are bringing business value in terms of like real world deployment. So we see companies from like oil and gas industries looking into drilling reports with LLMs or trying to analyze even like the 3D modeling of like wells and reservoirs, for example, right? Which doesn't make sense because it's not text, at least on the like a first look of it. But there are a lot of ways how you can train ML models which translate images to text and then put it into LLM and that kind of stuff. When this starts to be exciting and more interesting, right? Building like a simple chatbot to converse with is like fun activity, but getting a real business value out of it is not that huge.
Thank you. I'll keep asking strange questions though.
Yeah, that's all fine. So basically what we are mostly doing whenever we are trying to work with LLMs, in order to ask questions, we are preparing embeddings, right? So whenever we have any kind of text added as an input or as a question, we need to take the embeddings and put them and store them in an efficient way, like a vector store. So the open source one that we mostly use would be OpenSearch. And if you look at different ways how you can create LLMs, one is the like pre-training, so training your own. That's something that Facebook is doing with LLaMA, or other bigger institutions are doing with targeted large language models for certain industries. But most likely, you would either be doing fine-tuning if you have big enough infra to fine-tune it to your own use case, but also the even more popular, because of less hardware requirements, would be playing with prompts, with either p-tuning or any kind of prompt engineering tricks and so on. So obviously the pre-training then, yeah? I thought there was a question. So let me skip.
Just feel bad for me not asking questions for like 1 minute.
Yes. I'm going to skip a little bit to prompt engineering, because that's the important part, and that's how most likely you would be playing with the model. So basically, whenever you want to ask a question to a model, you can do a lot of things to make it more accurate. So first of all, you are using historical data from previous conversations, because the most standard use case in business would be a model for onboarding new employees. You have some internal knowledge base, you extract data from that into a vector store, and then allow people to interact with it, asking questions like, hey, how expensive dinner can I expense on my company card, or things like that. So you are looking at the historical questions. You can add some additional supporting examples, like, hey, I'm looking for an answer which is expressing exactly the monetary value of this. And you can put also a lot of context depending on who is asking, where they are located, because you have metadata from the browser and so on. So there are a lot of things that you can add into a question, and that's all called prompt engineering.
I have another question now. Can we detect bias, for example? That's a question I got a lot today, basically.
To detect bias for
For the answers, or any mistakes, for example.
So yeah, later on we will see the entire pipeline. So there is a last step of deployment, especially if you go to production, where you can do EDD pipeline, so like evaluation-driven development for the model, and then we can discuss that because it's easier on the picture.
Okay.
So what I wanted to talk about is the compute type. So basically, whenever you are trying to use any ML model, you need to decide on the infrastructure that you are going to train it on. If you have access to public clouds, that's one option. You can get a GPU access there and just create an instance or create a Kubernetes cluster. But there are also other places where this can happen. So it can be in your own private data center. There are also a lot of distributed compute pools where you are doing training, especially in the use cases where you have, for example, I don't know, a bank with 1,000 branches. Each branch has some pieces of compute. In telecom space, each POP site has some pieces of compute, and you can work there. And also there is the edge and IoT, because there are a lot of things that you can do, especially in like the last mile step of p-tuning something. You can do it on the device itself, either if it's a phone or any other more sophisticated device. And for this kind of deployments, whenever we are using open source components, there is an open source automation called Juju that allows you to take those pieces and deploy them regardless of what the infrastructure is. And there are obviously a lot of considerations about accessing GPUs, because this is a scarce resource. There is it's really hard to get your hands on A100s or H100s. There's a lot of lead time that you have to wait for the machines with that. Even on the public cloud, which is super annoying whenever you want to start an instance, you see like, hey, this region doesn't have A100 capacity, now come back later. That's like one of the most annoying messages whenever you want to start something new or start a demo. So what you can do is to utilize the infrastructure for your benefit. There are a lot of things that you can do on the lower layer, which is typically overlooked because people play with Jupyter notebooks or with Kubeflow, but don't look at the underlying layer of Kubernetes, of what you can do with the drivers and so on. And what you can actually achieve there is, first of all, things like GPU sharing in various different methods. You can use vGPU, you can use MIG, where you can slice a GPU into 8 pieces, for example, and then allocate Kubernetes pods to each of the pieces. So that allows you to put multiple workloads on the same GPU. You can also play a lot with Kubernetes scheduling mechanisms, where you can use priority for different teams and different workloads and schedule it like that. So that allows you to greatly increase the utilization.
I'll stop you here, actually. Are there questions on the infra side before we move further? Raise your hand. Say it out loud. I don't know. Nope. Let's move further.
Okay. So basically, whenever you, yeah?
So,
Sorry.
what would be the difference between for the ML stack, like for the traditional ML stack and the LM ML stack?
I mean, the main difference is, first of all, in LLMs, you will probably have a vector store, which was absent in traditional ML environments, right? So that's additional piece of infrastructure that you need to integrate to, so that you can do similarity search and you can extract information on your RAG pipeline. That's one area. The other different thing would be like externally available UI. Earlier, when we were training ML models, they were typically served as either like a Docker container with an API, or like Google Protobuf or something where you ping the model and get an answer. Here, the interaction with the user is super important. So you need a nice UI with nice user experience to have a chatbot, right? Because otherwise, it's not that beneficial. There are a lot of LLMs working on bad jobs in the background as well, but typically there's like additional component that needs to be there.
So, is it necessary to use any like LangChain or Hologene to is something that required for connecting all those like components together, or usually we can just use traditional ML orchestration tool to kind of connect those different pieces together?
Well, so I would not say it's like required, but it's highly advised to, because obviously no libraries are required. You don't even need to use TensorFlow or PyTorch. You can write in C bindings to your CUDA libraries and try to use your GPU directly, but that's not the most efficient way, right? If you want to build a project and you are not fighting over like 0.5% optimization, the higher level libraries are super convenient. And LangChain, from my experience, is the best one for playing with LLMs, because it allows you to conveniently chunk the textual data, and it allows you to automate the process of creating embeddings, and also it has nice integrations to most of popular vector stores and other tooling. So it's highly advised to use it. It's not like that it's mandatory, but if you are like a small team, it will just speed up your process a lot. So I would still go for it in most of the times. Yeah?
How are you splitting one GPU into 8 GPUs?
So there are a lot of ways how to share GPUs. The one that I was mentioning in like A100 specifically, you can put it into 8 slices with a thing called MIG. It's a shortcut for multi-instance GPU. And that's a technology that is embedded in NVIDIA GPUs. There are also other ways. You can do time-based scheduling, because then it's not NVIDIA specific. If you are using any other accelerators, that might work there as well. So there are different tricks on how to do it. MIG is most popular because NVIDIA GPUs are very popular. And then it also allows you to pool MIG slices across multiple GPUs, because sometimes if you have A100, it has 40 or 80 gigs of memory inside. If you want to put a bigger model in, you can have MIG slices from 2 or 3 physical GPUs and make them one pool. So that's like another benefit. You don't have to slice it to be smaller. You can also use those slices to actually make it bigger.
question there.
Yeah?
Since you mentioned RAGs, can you talk about the difference between fine-tuning and embedding model versus fine-tuning a large language model?
Yes, let me go back to this because that will be helpful. So that's, I would say, a typical architecture of a system where you have some internal files or internal knowledge base where you want to extract data from. So on the bottom left, you have your ingestion pipelines that takes like, I don't know, PDFs, text files, or whatever is in your work directory, exports from SQL databases, something like that. And then when you want to use this data, you need to split it into chunks. So like sentence or a couple of sentences, depending on like the chunk splitting strategies are different depending on the data types in order to get more efficiency. We can go to that later. But then you are using an embeddings model to create embeddings out of those chunks of text. And you put it in a vector store because of it's easy to search for them later. So that's like the beginning. It's sort of a pre-processing when you have this and have vector stores with embeddings. The whole process of asking a question would start. So the user creates a query. You can embed it, enhance it with some historical data and other stuff. And then what happens? What happens is the similarity search. So basically, we look at the question, like if the question is, what are my sales targets for 2024? It will go to your vector store and look for things that are languagely similar to that statement. So if there are like sales targets, it might look for sales quota because it's like language similar in terms of closeness in vectors because this kind of text comes well together in a lot of different docs that you would probably have. So then it will pull of this into context, and the actual question that will go to your large language model would be, hey, what is my sales quota for 2024? And take into account these pieces of information, and you will get like 20 or 50 sentences into the context that are coming from your internal documents that describe sales targets for Michelle, Josh, and Mike. You know from the context that the user that is asking is Mike, so you can tell him that, yeah, your quota is 2 million or whatever. So that's RAG, that kind of pipeline. So you retrieve pieces of information and you augment the question. Yeah? That's just an example of a model that you can use. So it could be LLaMA, it could be Falcon, it could be anything. So it doesn't really matter. The NeMo is also open source.
My question is, if you're using RAG instead of fine-tuning, does the model of like the maximum token that model can take actually going to be a limitation of bottleneck for using RAG?
Yes, so obviously the size of the context is the limitation. You cannot really do RAG with a way that, I don't know, you have 10 terabytes of data in your company and you put all of them into the context. That's not possible at all, right? I mean, it would require enormous infrastructure and no one does that. So obviously there is a limitation on the context size depending on the hardware capabilities you have. However, most of the questions does not require that huge amount of context. And what you can do, you can chain a couple of models together and try to minimize the context that is necessary for this particular question, especially when you have historical data and more users and you can compare those questions too. So, but yes, context size is a limitation. And if you have huge databases, like, I don't know, research institutes have, you have a lot of research papers. A lot of people are doing fine-tuning in that cases. If you want to have a model that is, I don't know, specific to research about atomic energy, probably RAG will not be your best ally in that case. Yeah, there was.
So the follow-up question on that is chaining on multiple models. Can you explain that?
Yeah, so basically whenever you have a couple of models that are fine-tuned for different things on different data sets or have different RAG pipelines. The example would be a company, like you have a foundational model, you take LLaMA as your go-to, let's assume, because it's easy to get and people know it. And then you do RAG pipeline on sales data, on marketing data, and on data from engineers. So obviously you will have 3 different models in your model repository that are fine-tuned. You can host them in your serving infrastructure. And then whenever a question comes, you can have a very small, simple, like low amount of parameters model that will just go through the question, skim through it and see, okay, that's an engineering question that goes to this LLM. Okay, that's a sales question that goes to another LLM. because then you can basically quickly move between them. Some of them will be complex and require more processing power. Some of them will be simple, so we want to have this kind of step in the beginning so that your query cost is lower. Because you could train one big model that knows everything about your company data and has a huge context size and can do marketing, sales, and engineering, but then this whole setup would be much more expensive. Yeah?
How are we combining and embedding from different chunks when we are doing the chunking model?
What do you mean combining embeddings?
Yeah, like, let's say we have a text that's too large for the context window that we are working with.
Mm-hmm.
We are chunking it, and each chunk has its own embedding.
Yes.
So how are we storing that in the vector store?
So the embeddings are stored directly in the vector store, chunks. So not the entire text, but pieces of the text. When you create embeddings, you store them into OpenSearch.
Okay, you're not averaging them or summarizing them.
No, because if you, well, you can summarize the text if that's something that you want to do, but if you want to have most out of your data sets, it would be much better to take the chunks and store them individually still. Because then whenever you do similarity search with KNN or something like that, you can retrieve all the pieces of information. If you do summarization, some of the information is lost already on that step, right? So it depends on what you want to achieve. If you are making a model that is for a law firm that needs to go on like legal precedences, I would not do any summarization. If it's a model for marketing something, yeah, why not? I mean, yeah.
Is there like best, I don't know, the scenario or a gold standard of how to combine different chunking sizes? Sometimes you have documents that articles that are pretty big, articles that are pretty shallow, and we're trying to like search for them in a specific chunk size. Sometimes you get only the smaller ones or the bigger ones. Is there like a way to combine different chunk sizes or?
Yes, you can have different chunk sizes, although if you are asking for like one method to tell you which chunk sizes are good for your use case, unfortunately there is nothing like that. It's a very new field of study still. So the best way to do it is to actually have a couple of tries and have an automated process. And that's why we are going into MLOps, because if you have a pipeline that does the chunking and all of this process is fully automated in a Kubeflow pipeline, for example, it's written in Python, you can rerun it. You just change one parameter, chunk size, run it again and see if the answers are better or worse, right? So you can easily experiment with it. If you would have to do it manually every time, it will get boring very quickly.
Could you combine it, for example, having one with a low chunk size and another one with a bigger chunk size, and having like a kind of hierarchical, like this chunk size cover these ones?
So this goes into chaining of the models that I mentioned earlier. So you have a first small LLM for pre-processing to tell you if it goes to sales or marketing or engineering, and they might have different chunk sizes, right? So then you can combine it. Also, what people do sometimes is like a serial chain, where you ask a question to a small LLM and then assess in the pipeline the answer quality. If it looks bad, you put it into another, right? So you can also get like small model, less processing power, less cost per query, then a bigger one, then like a huge one. So that you don't give users immediately access to a huge model so that the query cost is not too high.
So from a user experience perspective, so if you are chunking all these big files, and let's say you do a similarity search, and it found in one chunk, right? But the user wants to see the full document with where it matches that the question, right? So how does that user experience work?
So the user is not involved at all in the chunking process, right? That's something that happens in the background automatically. So whenever you ask a question, you get an answer for your question, right? You can also do it in a way that you present a user a links to a document from which these chunks are coming from, but then you don't put it in the context or in this process. The chunk just has in its metadata a link to a document it's coming from, and that's it. So you don't put entire document there, you just put a link so that they can access it. I mean, you can retrieve it in the UI in the background and make it like nicer, but I haven't seen that done quite often.
Do you have the architecture for the multiple chain?
No, but it will be very similar to this, just like copy this in your mind to the next one, and this will be a very similar process to. Sorry? No, not the bottom part, the top part, whenever you ask a question, right? Okay, good. So what I wanted to do right now, if you have your own laptops, we can try to set up. Yeah, exactly. So whoever doesn't, that will be less exciting because the second part of the workshop, as was stated in the invite, would be more interactive so that you can play with it and set up an open source LLM on an Ubuntu machine on your system. So that's something that we'll be doing all together. You can still stay and watch and try to follow it on the screen. Less exciting, but still. Yes. So how many of you guys are familiar with like a terminal and the command line and have that available? I assume most of you have Mac, so that should be fairly easy. Yes, no, maybe? Okay. So basically the first step would be to clone the repository. It has the example built in also with a README file that shows you how to do it. Andrea, where are you? Can you send the link to the repository on the app on the chat for everyone to copy it easily? So do you want like 3 to 5 minutes to set up? Because I heard WSL2 from that table and some people are trying to set up. Are you okay with the internet and everything here? You have like local Wi-Fi? Okay. So on the repo on GitHub, you also have a description of the example. So let me tell you what's here in the beginning before, like while everyone sets up. So this demo will have 2 different applications. One of them will be the embeddings app, and that's like basically a UI that you can drag and drop any file that you have, like a PDF or text or whatever. And this will generate embeddings and store them into a vector DB. And the other one is a chatbot app, like a simple UI. You put a question, you get an answer, right? So that's there. And the environment is based on Conda. So there are all the requirements files in Python there. And it can work with the GPU support or on the CPU. If you will be running it on the CPU, it will be pretty slow. You will have to wait half a minute for an answer. If you have an access to an instance with the GPU, it will be much faster. There are a couple of configuration parameters exposed in terms of like chunk sizes and path to a database and so on. The most important one is like use GPU. If you don't have a GPU, that should be set to false, otherwise it will not work. So
The link is in the chat.
yes, what chat?
Comment section of the app.
Okay. Awesome. So the first thing that we need to do is to create an environment for it.
have the environment set up first thing first. Not too much. I know you have it.
So internet here is very slow. Let me do it over the phone, it should be better. So how bad it is in terms of the internet? Okay.
That is an answer. That is an answer.
Yeah, that answers a lot.
In this case, something that we could do, first of all, I think the session is recorded, so you will have it, and then also, Maciek, we can send the PDF and the necessary sources for everyone to try to go.
Yeah, but my internet is as slow as everyone else's.
If you have hotspot, I don't know. Okay, fair enough.
Yeah, all the libraries won't work with different architectures. So.
Some of the content, like the recording,
But
will
yeah,
be available.
the libraries are
So the internet, so you get the bandwidth. When you install ads around,
Yeah, like, I mean, this was this is a
But in this case, should we go back to maybe use cases or challenges that usually you see companies facing when they try to build LLM projects, except for the network, Maciek? Challenges that we see on LLM projects, except for the network, of course.
Yeah, so let's make it then interactive sessions with questions since the internet is not loving us today. So Andreea was asking about the biggest issues that we see in terms of people deploying LLMs inside their networks or in commercial settings. So first of all, there is a lot of questions and doubts about security of all of this because most of the libraries that are being used are like 3 months old or 2 months old and no one knows where they are coming from. So that's one area. So basically what we are trying to do here, so with the Kubeflow community, is to maintain a set of images which have all of those libraries maintained and CVE patched and fixed. We publish that upstream. Andreea is representing like the Kubeflow community as well, so we can pull images from there and have that type of stuff secure in a way that makes sense also in enterprise settings. Another thing that is being asked a lot is a question about like what happens with the data when you have your LLM hosted on the public cloud or some other location and you are hosting, like you are using your internal data. So there's no good answer for that. If you are running your language model as an API to somewhere else, you will be sending your data, especially if you are doing any kind of RAG kind of stuff or embeddings and so on. So that's another problem. But what would be more interesting would be to hear from you guys. Do you have any issues that you have internally while trying to convince people to start building or using LLMs inside your own environment, or if you're a consultant in your customer's environment and so on?
according to the answer that we build our own, like train our own LLM, but it seems as good as we use ChatGPT or not ChatGPT, but GPT-5 or is there a way that we can get like a higher quality answer?
So if you are talking about training your own LLMs, this is really a silicon game. So it's like the data sets are mostly public and available. So in order to have a better model, you either need to have a really nice breakthrough idea about like network architecture and so on, which is well difficult to get with the other research and innovation centers doing that. So the only thing that you have left is number crunching, and obviously, like, I'm not sure from the latest numbers, OpenAI has like 25,000 GPUs from NVIDIA. So if you want to beat the quality of the model being trained, you need to beat that in terms of hardware capacity, which is very difficult.
I guess what I'm saying is that I have my own data set, right? Like, kind of like novels. But
Mhm.
I want to train my local LLM so that the quality of answer is, better. Because it's not going to be inside GPT.
Mhm.
So is there a way that I can get a high quality answer from a local LLM?
So, yeah, so my suggestion would be not to actually train from scratch your new LLM, but take a foundational model like LLaMA or any other, and either perform fine-tuning process or play with prompt engineering or RAG or other techniques like that, instead trying to train your own LLM on your internal data.
So that is what we try.
Okay.
We took like a base model and then we tried to train it on our data set, but the quality of answer did not sound very good. So I didn't know if there was any other technique process.
So,
Or people have been talking about RLHF as another technique.
yeah, you can have a human in the loop basically assessing the answers, but that's also something that you can automate because there are a lot of ways whenever you know what should be a good answer for a question, you can have a batch job that has like 200 most typical questions that you would ask to your knowledge base and how the answer should look like. And then whenever a new fine-tuned version or new p-tuning or prompt engineering happens, you evaluate the answers of it in a batch job for those 200 questions, how far they are from the exactly good answer, and repeat the loop again with different parameters. After some time, you are getting to at least like local maximum kind of optimization for that.
Is there a certain like size that we need to have in terms of that initial training data set that would be?
What do you mean size?
Like the number of examples, like, we have our knowledge base, right? But let's say our knowledge base is only a certain, like,
Mm-hmm.
is there a certain threshold that's required in order to be able to get good quality?
It's very hard to say about like strict required threshold because it would depend on your knowledge base size, but also the variety of it. Because if you are like the last project that I was doing for an automotive company, for example, they have a bunch of documentation on how people who are putting cars together should work on a certain station, and some ECNs like engineering change notes and things like that around the process. So all of them were fairly similar in terms of like, okay, you are basically welding these two pieces of metal or putting cars on the wheels on the car and that kind of thing. So the language, like if you look at wording, this is very similar, and also the whole like a problem space is small. So obviously in their case, the amount of things that you need in terms of examples for automated loop of assessing the quality would be small. But if you are doing like a wide marketing agency doing, I don't know, some posts in social media, then the vastness of amounts of words and text and that could be used is much bigger. So you need to have much more examples to assess the quality. And also quality in that case is very much more granular because a small difference in the messaging can make your marketing post viral or no one reads it. In engineering and putting cars together, there's like you can screw the screw to right or left and that's it. I mean, there are not that many options, right, to make the messaging bad or good.
There's a question here.
Yeah, sorry.
So the car example,
Yeah.
you had a lot of sketches, illustrations, and text.
Yes.
How did you handle the multimodal aspect?
So basically, there are a couple of ways how to do it. One is to summarize the images to text. The other option that you can do, because most of the engineering, especially because it was a German automotive company, they are very well structured, and most of the images that they have are generated from a textual format. So they have either like LaTeX kind of syntax that will generate the charts and diagrams, or any other thing that is actually already in form of text or language. So you can use that. If you would have like freehand drawn images, that would be super difficult. I don't think it's possible really.
I feel that there is a pain here. with
Yes.
that. How do you translate that?
Yeah, because engineering diagrams works a little bit differently because they are all vectors themselves actually, right? So that works much easier than like pictures or photos. Yeah?
We have knowledge base, existing knowledge base. We could have screenshots of applications, and then
Yeah, summarizing screenshots, it's not something that I've seen successfully done anywhere.
another question on evaluation. So, what are some techniques that, in your experience, you have used for evaluating the quality of response? It could be question answer or summarization.
So in the question and answer case, as I said, the easiest one is having a bot job that has typical questions and typical answers that I would expect written by a human, and then looking how far they are in terms of similarity, the answers from the model versus the answers that I would expect. Like, that's the simplest one. But also what we are looking for is the time of the user spent on the platform. Because if they ask a question, for example, and depending on the interaction and like user experience data from the front-end application that they are using, if they close it immediately, probably the answer was not that great. If they had to ask 20 follow-up questions, the answer maybe was not that great in the first step, So basically, by looking at the end-user interaction, you can get a lot of metrics about judging how happy they are with an answer. It's not a metric of quality, though, because users might be unhappy with the answer because they don't like it. Like if you ask questions that are...
I get my refund? No.
Yeah, exactly. So...
There's another question there.
Yes?
If the use case is more specialized and we're not looking at sort of coming up with creative answers to questions, it's more on specialized knowledge, how can you start to eliminate hallucinations? Are there any best practices that have come up recently on if you're looking at specialized corpus, how to sort of eliminate made up stuff?
Well, RAG is helping a lot, right, in eliminating hallucinations. Also, all this EDD loop, RAG, R-A-G, the whole like retrieving the chunks and so on. So that's one that helps a lot. The another one that helps a lot is actually running the model through the loop of testing that I mentioned with like pre-made question and answers and how they should look like. But in a very strict environment, like for example medical or legal, what you can also do is to limit the answer space by limiting the wording space, because you can eliminate words which are completely out of the domain, right? If you are working in a medical space, you can cut out everything that has wording from, I don't know, telecommunication or something that has nothing to do with what doctors would do, right? So then you are cutting out a lot of search space, especially when you do like similarity search on your vector store, or then you evaluate the answer. You are cutting out things that will never exist, right? Because in entire corpus of your knowledge base from, I don't know, doctor's appointments and like the patient data and so on, you'll probably not find a lot of like, I don't know, railway bolts or something like that, like wording that makes no sense in that space or context.
There's a question there.
Yeah?
When implementing LLMs on internal data using something like RAG, one of the things I've found is vector databases are quite expensive. So is there like a cost-effective way that you've found?
So first of all, what do you mean by expensive? Because there are open source databases that are free. So
But we go back to what's in our DNA, right? Because everything that you see here is actually open source. Open source is open source. You can try it out.
Okay, so I guess I would say in generating the embeddings, then.
you mean expensive in terms of the infra cost that you need, like GPUs and so on? Well, there is no good workaround on that in terms of like needing computing power to generate embeddings. This will be compute intensive. There are a couple of ways how people are trying to lower the cost. So first of all, they are using dedicated services with dedicated silicon on public clouds like Amazon Inferentia and so on, or Trainium in that case, in order to have that. Some people are moving to different architectures, working on ARM, for example, because there you have much more cores and you can also try to do it in a cheaper way. If you are not into having it done as a pipeline every hour and super fast, you can do a slow processing over a cheaper hardware. There are also a lot of other hardware vendors which are starting to get traction on the market, like Intel is putting out their own GPUs, AMD is doing that as well. So obviously they are entering a new market, they have to compete on price. So that will be also a cheaper option if you are not looking like for top-notch performance, because still there is nothing out there like H100, right? But if you want to go cheaper and slower, you can. There are other options.
Do you have any other questions?
So there's a ton of research going on around small language models and with large language models. People see with RAG and fine-tuning that a lot of times it doesn't generalize well. And creating your own model, you need tons of compute, GPUs, and great networking infrastructure. But in the future, could we avoid some of that and create small language models on business-specific technologies? How do you see that? Any references?
Okay, I think that if we want to go into an angle of let's not reinvent the wheel in 100 places all around the globe training the same model, we should go what we did in the software. Because when the whole like Ubuntu and all the Linux movement started, we went open source, right? So that not 100 people write their own text editor, write their own file management system, and so on and so on. This is now common. Everyone uses Vim or Emacs depending on from which camp you are. But basically, there is something that is being created. There is a pool of people, the community around it. I'm sure that that's exactly the same that's going to happen in the LLM space. So we will see 2 or 3 foundational models being developed and trained by the input from the entire community and then reused in multiple places. Then there will be another layer of models that are fine-tuned on certain data sets that would, in my opinion, still be open source, like model for medical data, model for financial information, that kind of stuff. And there will also be tons of people who are making paid products on like the lowest layer of that kind of stack, where they will give you an API that you can put in your billing statement and get some info about how to start living more frugal life or something like that. So I think that this is more or less where we will end up in a year or so. But the small language models, I don't think that this will be something big, because it's not big.
They're supposed to be small, though.
Yeah.
Do you have questions? Do you have more questions?
Fine-tuning, do you bring 2 options of fine-tuning with some open source options?
Open source options of?
For fine-tuning.
So basically how we are mostly doing that, we are using a Kubeflow pipeline where we create steps for fine-tuning. So basically you create a Jupyter notebook that does the fine-tuning for your particular use case, and then we convert it to a pipeline so it can run automatically over several iterations. And then we are also using MLflow as like a model registry and store, so that we can have multiple fine-tuned models, compare them together, and so on. So that's the tooling that we typically would use in that case.
Are you familiar with Kubeflow?
Yeah.
Do we have any other questions then?
So in order, yeah?
I have another use case if I can ask about it.
Yeah, sure.
So one of the things I want to try to do is get like a huge corpus of data, right? It's not like a knowledge base where there is a specific question and answer. Like let's say a book. I just want to read a book into a large language model and then be able to ask it general questions. Is there any possibility of doing something like that?
That's exactly that. So you can, instead of sales report PDF, you can put a PDF with a book into that example that is on the screen.
But like one of the things I'm trying to do is just say, can you summarize this book for me?
Yeah?
So we will be able to, because the context windows are still fairly small.
Yeah, but if you want to summarize the book, it doesn't mean that you have to summarize it in one go. You can have a book, a big PDF, summarize each and every chapter, have a longer file, and then summarize that file and have a summary of the book. Okay, so what we will do, we will send to each and every one of you the whole step-by-step recorded process of building that, so that you can follow it at home and have fun with what was actually planned for that workshop in a place where the internet is better.
Maciek, you already talked a bit on the, and before we wrap it up, on the future
Would
of...
it be easy to follow?
Sorry, can...
The step-by-step execution of the process, would it be easy to follow?
Well, I will record what I'm doing, so you can pause it in any time, so it should be fairly easy to follow.
Now you committed on the stage, by the way. You know that. I was about to ask you, Maciek, you talked a bit the future of LLMs. Where is the future of AI going?
I don't know.
Come on.
No, I mean, I think that no one knows. I mean, obviously, a lot of people have some like hopes and expectations on where it should go. The realistic prediction you can make around like 6 months into the future, not more. A lot of people are waiting for like things like AGI and so on, or ASI even, but that's not something that's going to happen tomorrow. Also, this is a very dynamic field. There are a lot of good inventions happening, so it's super hard to say. I don't think that anyone telling you what's the roadmap for next 3 years for AI is telling the truth.
I'm about to challenge that. I do think that the future of AI in general is going to include a couple of things, including open source as an entire, or as a preferred version, as well as applications that benefit more from iterative processes. What are your thoughts on that?
Not much. I mean, I still
don't
think
want
that, yes, open source will be the way to go in that terms, both not only for the tooling, but also for the models and for the data sets, because that's the only way how we can make it sustainable. The biggest problem is that if every F500 company will want to train their own LLM, they'll just use huge amounts of power with no sense. So I'm sure that will be limited in a way, one way or another.
And it's worth mentioning, I don't ask Maciek a lot of things just now. In general, we have a podcast together where we also invite different leaders from the industry. It's called Ubuntu AI, and we talk about different topics. We had one on Gen AI. We never talked about LLMs. And Maciek still wants one on AGIs, but I refuse doing that.
It's called Ubuntu
AI. Yes. It's on Spotify, Apple Podcast, most of the famous podcasting platforms, I would say.
Yes?
Do you see regulation around AI using also an open source initiative in itself, or do you think that that's something that I'm concerned about?
I'll take that.
No. I'm a huge hater of any regulations on science in general, so I will have a very biased answer, but I don't think that science should be regulated in any way, shape or form. Unfortunately, we see a lot of that. I'm coming from European country. We have AI Act right now, and we have a lot of strange ideas into putting like open source communities at risk by basically keeping them liable for someone using the software, which makes completely no sense, because if someone downloads Ubuntu and then hacks a bank, we should be liable for that. I mean, that's like awesome idea.
At the same time, I completely disagree with that. I think it's important to offer people and companies guidance on what they look at and how to approach AI and MLOps in order to ensure that actually their use cases, their data is secure on one hand, but also on the other hand that actually the end users that they would benefit from the project would not be put at risk in any way.
Guidance always, regulations never.
We don't agree.
I guess I have a very specific use case that I'm concerned about, because we
Yeah.
have agents talking to each other now. What if agents figure out how to hack like a bank account, and then like, who's going to be responsible for that? Because it's agents talking to each other. Like I may have contributed to that open source package, but I didn't do it. This is some other end user who did it. How would that work?
I'm not a law expert. I would not know how to answer that, to be honest. But this is exactly why I think it's important to have guidance and regulations to actually know how to answer these kind of questions. Whose fault it is? How do we ensure that if that happens, or if it happens once, it won't happen again? And how do you provide guidance even to open source projects to ensure that actually they build a secure platform to avoid situations like that? Okay. Is there anything else that you would like to add, us?
Actually, so for the RLHF, is there an example of trying to implement that in C++? I've never seen an example of that.
So imagine it like as you have a UI next to a chatbot. Whenever you ask a question, there is thumbs up and thumbs down, or more complicated, like 0 to 10 grading of an answer, and you keep that data as record. And if you see your model having all thumbs down, maybe retrain it. Yeah, but you have different parameters, right? You can have different, you can use different foundational model, you can use different parameters, different chunk sizes. There are a lot of things that you can, like knobs and dials to manipulate, right?
Okay then, if you do have questions or you would like to talk more to Maciek or I, we are downstairs. And also all our colleagues, they usually wear the orange Ubuntu t-shirts, so feel free to meet us as well. Thank you.
Thank you.